Hello again. Now we'll be discussing the detailing of RC beams and actually the detailing of any reinforced concrete members, because here we'll be discussing some very important concepts about bond strength, development length, and left splice. So the concept of development length is simply that you need a certain length in order to have a sufficient contact surface area between the steel bar and the concrete, surrounding concrete. So this development length we call it here LD. So simply you have the axial force in the bar is should be equal to the bond force. This is the equilibrium. So simply the cross-sectional area of the bar multiplied by the bar strength is equal to the bond strength times the area in contact with concrete. So if we have this equation written in this manner, so here we are having the area of the bar multiplied by the strength of the bar multiplied by the contact surface area with the concrete multiplied by the bond strength of the concrete. We'll get this equation that this is the development length. Of course, this involves a lot of numbers, a lot of calculations, but we'll have some rules that will help us. So we have, if you look at this equation, you'll notice some factors governing the development length. First is the bar diameter. Second is the end conditions of the bore. So if you have it ended like this, for sure it will be different than if it is cut up down. The bore surface condition, whether it is having detonations or not. The position of the bar in the former itself, the steel yield strength, and the concrete characteristic strength, which will have a direct effect on the bar. So the Egyptian code actually it gives a more simplified equation, including all of these factors. So here this phi is the bar diameter, alpha is the end condition and shape coefficient, beta is the bar surface condition coefficient, which will change whether the type of steel is mild with smooth surface, or it is with detonations, it's height and side with detonations, so they will change for sure. Neta is 1.3 if it is at the top of at least 300 millimeter beneath, or else it's equal to 1. The concrete bond strength is satisfying this relationship, 0.3 root FCU over gamma C. And LD should always exceed the following values: the larger of 400 millimeter or 35 for 5 for smooth bars, or 300 millimeter or 45 for deformed bars. And this table will show us the factor alpha, and you will understand here why does it change. I mean, if you are having this this type of end condition, whether this hook or this 90 degrees or um, this angle, whatever, all of these, if it is in tension, it's a factor of 1. However, if you don't have any of these conditions, if it is just like that, left like that, okay, it's 0.7 or 0.5 depending on the case. So this is a very important issue to understand here. Okay, what's called il-gansh in Arabic. You'll find the terminology said by the labor in Egypt, hadid megannish. Okay, excuse me for using some Arabic terminology here, but it's very important to give you this terminology if you will go to sites and that idea. Also, if you don't want to use this equation at all, if you don't like that equation, so these are the factors given by the code. So you multiply this factor by phi. Okay, simply multiply this factor by phi, then you'll get the development length. So depending on the concrete strength, if it is 20, it's 65. If it's 25, it's 55 pi. You'll notice that the higher is the concrete strength, the shorter is you need a development length. So it makes sense, especially in tension direction. Okay. So this will take us to the bar cutoff in beams, which is directly related to the development length. So where do I simply don't need the bar anymore? So here, if I look here at a certain section and I look at the diagonal tension crack that will happen, I will understand something very important, that here I am talking about the couple between compression and tension. And because of that, this is the point that theoretically speaking, you could have the end of the cutoff. So I could simply cut the steel here. But do I cut it here? Practically no. I need to move a distance beyond this point. Why is that? Because this bending moment diagram actually could change depending on the load, depending on the support conditions, depending on the partial fixation you are talking about, depending on a lot of things. This LA is actually the larger of D, or 0.3 D plus 10 phi. And this distance, the lower reinforcement should always continue. At least 1/3 of the lower bar should be extended along the dimension, even 150 millimeter beyond the column center. The upper rebar should be extended by the largest of D, or 0.3 D plus 10 phi, or 0.3 D plus L over 20. These are the rules stated by the code here. Okay. Type. If you look at this very busy diagram, there is a very important concept here related to the development length, LD, of 0.3 plus 0.3 D, and LD, in some cases only LD, which is the overlap between the upper reinforcement and the lower reinforcement, and the distance from the point at which you don't need the upper reinforcement anymore and the real end of this upper reinforcement. This is how you will understand this diagram, which is actually taken from the code. So this is something very important for you guys to understand, especially if you are working as site engineers, especially when we are dealing with shop drawings. Because if you find boards that are cut off at arbitrary dimensions that are wrong, actually, you need to be aware what is the right thing to be done about that stuff. So again, you should understand that there is a general rule that no bar is to be terminated in a tension zone unless one of these two conditions apply: that the shear stress is significantly low, or additional stirrups are provided in this manner as shown according to this equation. Other than that, you should not allow termination of bar within a tension zone at all. Lap splices. Lap splices is what's called in Arabic al-ashayr, and the single form of it is ishara. So this is where you have one bar ending and another bar receiving starting, and there is an overlap between them. Again, this is not allowed in tension tie members. So if you're talking about the tension column, for example, and this is a very rare cases. However, when splicing, different diameter length is based on the larger for sure. So here, if you are talking about if this is a beam or this is a slab or this is whatever, and you need to have the cutoff, the lap splice between them. So this lap splice is having the development length dimension. Okay, and if there is an overlap between more than one bar together, or a set of bars together having several lap splices, then this overlap should happen between plus or minus 1.3 LD or more. And the minimum lap splice for welded mesh tension is larger of 150 millimeter and 1.3 of the development length for the core bars, or 200 millimeters and 1.5 of the development length for smooth bars. Okay, I hope I was straightforward in this providing this information.